Hi everyone, in this video I will be discussing about evaluating definite integrals. So previously I have been talking or discussing from the previous topics about indefinite integrals. So this time we will be having definite integrals. So for definite integrals we have this formula, that is the integral of f of x dx from a to b. This is our limit. The lower and the upper limit is equal to f of x. And if we evaluate this one from a to b, we will simply be subtracting the value that we will be getting from b and to a. Just to recall though, for indefinite integral, the formula was the integral of f of x dx is equal to f of x plus c. So if we will be solving for this one, our final answer will be a certain function or a certain expression followed by the constant of integration c. But here, for definite integral, from the word definite, we will be getting an exact value for our function. Let's have an example. Number 1, the integral of x dx from 2 to 6. So even if this is a definite integral, still we will be applying the rules that we or you have learned from indefinite integral, but later on we will be substituting the value of our limits. So this one, the integral of x dx, we can apply the power rule, if you can still recall. So power rule, the integral of x raised to n dx, that is equal to x to the power of 1 over n over, x to the power of n plus 1 over n plus 1 plus c. But again, for definite integrals, we won't be writing anymore c. So simply evaluate or look for the integral of x dx, that is x to the power of 2, because we know that the exponent there is 1, so plus 2, whatever your exponent is, that will be the denominator. Now evaluating, so we simply substitute the value of the lower limit and the upper limit to the function. So we start with the upper limit 6. So x will be 6 squared over 2 minus, we will be subtracting value of the lower limit, which is 2 squared over 2. Now simplifying, 6 squared is 36. It's 36 over 2. 2 squared, that is 4 over 2. 36 over 2 is 18. 4 squared over 2 is 2. Therefore, the integral of x dx from 2 to 6 is equal to 16. And that is our final answer. For the second example, we have the integral of the quantity of x squared minus 2x plus 4 dx from 3 to 5. So here we are given 3 terms, and for this one we can actually distribute the integral symbol to each of the terms, so we can integrate each one of those terms. So starting with x squared, applying the power rule, that is x cubed over 3 minus, that's 2 x squared over 2 plus the integral of 4 is simply 4x. Now we can further simplify this one. That is x cubed over 3 minus x squared plus 4x. Now evaluating from 3 to 5, which are our limits. So that is we start with the upper limit 5. That's 5 cubed over 3 minus 5 squared plus 4 times 5 minus subtracting the lower limit, that's 3 cubed over 3 minus 3 squared plus 4 times 3. So simplifying, 5 cubed, that's 125 over 3. 5 squared is that's negative 25 plus 20 minus this is 27 over 3, which is 9, minus 3 squared is 9 plus 12. So this will be 0. What will remain is negative 12. So that's 125 over 3 minus 25 plus 20 plus minus 12. So all in all, this is negative 5 minus 12, that is negative 17. So that is 125 over 3 minus 17, and subtracting, that's 125 minus 17 times 3, that is 51. So we will have 74 over 3. So that is the integral of this function from 3 to 5. For our last and third example, we have the integral of sine x dx from 0 to pi. So to recall, we already know the integral of trigonometric functions. We know the integral of sine x dx. So the integral of sine x dx is simply negative cosine x. Now evaluating from the given limit 0 to pi, simply substitute the value of x by pi and 0. So that's negative cosine pi minus negative cosine 0. Now you can actually solve this one in your calculators, but we can simplify this one first. So plus cosine 0. So using our calculators, or if you know the unit circle, you will be able to know the value of this one. But to make it simple, you can actually input this one in your calculator. So negative cosine of pi, that is negative 1. Now for cosine 0, that is equal to 1 still. So simplifying, that's positive 1 plus 1, that is equal to 2. So that is the integral of sine x dx from 0 to pi. If you have any questions or clarifications, feel free to comment your questions on the comment section below. You can actually, or you can also ask your questions in our group chat or you can send it via PM. For your attendance, simply comment your complete name and your course and or block number. Thank you so much, you guys. You take care always. Bye for now.